Hello viewers, in this video I'd like to discuss about the vertex cover problem and NP completeness of vertex cover problem. So very first question, what is vertex cover problem? It's a graph optimizing problem, and input here in this problem is a graph. G is equals to vertex and edges, and K is a natural number. Output will be, it's a decision problem, so output will be yes or no depending on the some condition. So output will be yes if there exists a subset of vertices of the subset of vertices B such that the cardinality of B will be less than or equal to K for each edges E in the graph. In the graph, each edges in graph, we have at least one vertex cover. That is, we know that in each edge we have one U and V edges. So for all U and V, we will have at least one of the vertex cover. So here we can formally say that one vertex in V prime, that is means for all UV which belongs to U, we have the intersection of UV with V prime, there will be not empty. At least there will be one vertex cover. So output is no, otherwise if the condition is not fulfilled, then the output will be no. Now let's see the example, then it will make more clear. We have one example here, a graph. For the first graph, you can see that normally we have a graph and it has a node. You should understand that the pointing are the vertices and the lines are noting the edge. So it has 1, 2, 3, 4, 5 nodes. Now totally in 5 nodes, but the big circles are pointing the covering node, so vertex cover. So if we have a situation like this, 5 is equals to 5 vertex, and if we have um, a subset of V is 3, then it is covered. So you can check that these 3, all of the edges are covered. So for this situation, output will be yes. Another example, it's a big graph, little bit big. So it has how many vertices? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total V is equals to 13. And if we take K is equals to 5 for the situation, then output will be yes, because you can check the big circles. You can see that each of the edges are covered. So this is one of the example of vertex cover. For this 5, for this second graph, if we take the K is the maximum coverage, vertex coverage, then the graph will be covered. In this example, it is confirmed. We can easily see that vertex cover is in NP, because in the book of Gary Johnson is mentioned it very clearly that how we can see that vertex cover problem is NP complete, and we know that any problem in NP complete fulfill two conditions. The first one, the problem should be in NP class, and then all other problems in NP will be polynomially reducible to that problem. So vertex cover problem is, first of all, from this example we can confirm that a vertex cover problem is NP. It is easy to see that. So we are going to prove the vertex cover problem in NP complete. For that, the first step, it is easy to see that vertex cover problem is NP since the non-deterministic algorithm Since a non-deterministic algorithm need only to guess a subset of vertices, we are guessing this B prime subset of vertices and check in polynomial time whether the subset contains at least one of the endpoint of the edges and has the appropriate size. So you can see that in these two graphs, all of the like first example and second example that you can consider the second example, the k is equals to 5 and b prime cardinality subset is 5, and that covers all the edges endpoints. So uh, and it can be countable in checking can be possible in polynomial time. So lattice cover problem is NP class. So the next is reducible. We know that there is a transformation. We can transform three set to vertex cover, and that confirms that NP vertex cover problem is NP complete. For that, we need to do certain steps. Like for three set, we need to we have, let's say we have an instance of three set u is equals to u1 u2, or you can say x1 x2 xn, and then you can say okay, we have a clause c1 c2 and cm. This instance and variable need to convert it into equivalent graph, and the position positive integer of k, which will be reduced smaller than the vertex node, but um, and then G has a vertex cover of size k or less if and only if C is satisfied. So that is the main point. That means that as the previous proof, the construction will be made up of several components. In this case, however, we will have a truth settings components and satisfy testing components argument by the additional edge for communication between the various components. This is written in book. Okay, so I will check in next video with the instance with the three set, and you can also read this book, the Gary Johnson book. So there in detail very nice explanation are there, but in next video I will discuss how can we make this book. So thank you for watching this video.